Section 12.3.7. Constructing an S-box. Here are three methods for constructing an S-box with good non-linearity properties: the clock method, skip mix, and the MELD8 method. Clock method. On a sheet of paper, arrange the letters of the alphabet evenly spaced clockwise around a large circle, like the numerals on a clock face. Choose a starting letter and a second letter, and draw a straight line from the first to the second. Then choose a third letter, and draw a straight line from the second letter to the third letter, and so forth. Define the span of each line to be the number of letter positions you move forward in a clockwise direction from each letter to the next. For example, using the 26-letter alphabet, the span from C to D is 1, and the span from D to C is 25. To make the substitution as non-linear as possible, make each span a different length. Here is how it can be done. For each letter of the alphabet, make a list of all the letters that can possibly follow it. When you begin, the list for each letter will contain every other letter, so you would have 26 lists of 25 letters apiece. Each time you choose a letter and add it to the mixed alphabet, delete that letter from all of the lists. If the span from the previous letter to that letter is S, then also delete any other letter whose span is S from all of the lists. For example, suppose you have added P and then R to the alphabet. The span from P to R is 2 positions, PQR. Therefore, in the A list, you would delete C. In the B list, you would delete D. In the C list, you would delete E, and so forth. Eventually, some lists become empty. If there is only one letter whose list is empty, then that letter will have to be the last letter in your mixed alphabet. If there are 2 lists that are empty, then you have hit a dead end. Start over or backtrack and try again. Each time you choose the next letter to add to the alphabet, choose a letter that has a short list, but not one with an empty list unless that's the last letter left. Historic aside. This heuristic is called Warnsdorf rule for H.C. von Warnsdorf, who used it in 1823 for constructing knights' tours on a chessboard. An improved version that looked 2 moves ahead was given by Ira Pohl of UC Santa Cruz, circa 1965. Here is an example of an alphabet constructed by the clock method. There are 5 different numberings that need to be tested to check the linearity of this alphabet: the N1 numbering, the first and second digits of the N2 numbering, and the first and second digits of the N3 numbering. Each of these must be correlated with the same 5 numberings for the standard Latin alphabet, making 25 correlations in total. You want all of the correlations to be between -0.5 and +0.5. Even better would be to have them all between -0.333 and +0.333. Here are the results of those tests, the 25 correlation coefficients. As you can see, all of the correlations are between -0.226 and +0.288, with 6 of them falling between -0.1 and +0.1. So the clock method is an excellent method for constructing non-linear substitutions. There is no guarantee that you will get such good results every time. You still need to test for linearity. Skip mix. Earlier in this section, 12.3, I mentioned that an alphabet could be constructed using the skip mix algorithm, section 5.2, with a pseudo-random number generator. In general, choosing an alphabet at random does not lead to good non-linearity properties, so let me describe the best way to use skip mix in more detail. This time I will illustrate with a 256-character alphabet. As always, you begin by listing the 256 available characters. Generate a random number in the range 1 to 256 to select the first character. Suppose that is position 54 in the alphabet. Take that character and then delete it from the list. Now there are 255 characters left. Generate a random number in the range 1 to 255. Suppose that number is 231. The next position would be 54 plus 231 equals 285. Since that is greater than 255, you subtract 255 to get 30. Take the next character from position 30 and delete it from the list. You have now taken 2 characters, and there are 254 characters left, so you generate a random number in the range 1 to 254, and so forth. The resulting alphabet has good non-linearity properties because you generate the random number in a different range each time. This is loosely analogous to making all of the spins different in the clock method. Here is an example of a 26-letter alphabet generated by this version of SkipMix. This can be tested the same way as the clock alphabet. The results are... These results look good. All of the correlations lie between minus 0.127 and plus 0.344, with 5 of them falling between minus 0.1 and plus 0.1. However, they are not as good as the clock method results. MELD8 method. This method is basically a special-purpose pseudo-random number generator. I will assume that the computer language you are using is able to operate with 64-bit integers. Depending on the way large integers are represented, you may be able to handle integers up to 2 to the power of 62 or 2 to the power 63. To be cautious, I will assume 2 to the power 62. The first step is to choose 2 numbers, a multiplier m of 24 to 26 bits and a modulus n of 35 to 37 bits. The modulus must be a prime. It is best if m is a primitive root of n. However, since I have not explained what that is yet, just make both m and n prime. Test your choices of m and n by multiplying them together. If the result is greater than 2 to the power 62, or about 4.611 times 10 to the power 18, then make either m or n smaller. To generate the random numbers, start with any integer s between 2 and n minus 1 as the seed. Multiply the seed by m and reduce it modulo n to get the first pseudo-random number. Multiply the first random number by m and reduce it modulo n to get the second random number, and so forth. That gives you a sequence of random numbers in the range 1 to n minus 1. You will use those random numbers to generate the alphabet. Suppose n has 36 bits. Number the bits of n from 1 to 36, starting at the high order end. Take the first 8 bits of each random number, bits 1 to 8, delete them from the high order end, and exclusive OR them with the next 8 bits, bits 9 to 16. This is the MELD8 operation. Its purpose is to make the sequence of characters non-linear. Here is an example. The next step is to use the 28-bit random number to generate a character. This depends on whether you are building a 26-character or a 256-character alphabet. For a 26-character alphabet, multiply this number by 26 and divide by 2 to the power 28, or shift right 28 places, to get the next character. For a 256-character alphabet, just divide by 2 to the power 20, or shift right 20 places, to get the next character. Start with an empty alphabet and add 1 character at a time. If this is a new character, you append it to the alphabet. If this is a duplicate, you discard it. Since you are not taking consecutive random numbers, this also works to make the alphabet non-linear. Here is an example of such an alphabet generated with the modulus n equals 90392754,973, the multiplier m equals 23165,801, and the seed s is 217934. The resulting correlation coefficients are: the correlations range from minus 0.170 to plus 0.267, with 11 of them falling between minus 0.1 and plus 0.1. This is the best of the three examples. However, it would be folly to conclude that MELD 8 was the best method based on a single example of each technique. Always test. Section 12.3.8. S-box with a key. In section 12.3.7, we dealt with S-boxes that had no key. They performed a simple substitution. When a key is used, the S-box performs a general polyalphabetic substitution, section 5.8.3. The S-box can be considered a tableau, with each row being one mixed alphabet. The S-box can be generated by constructing each of these mixed alphabets using the clock method, skip mix, or MELD 8, or by any combination of methods. If you use the clock method or skip mix, use a different random seed each time. If you use MELD 8, it is acceptable to use the same modulus each time, but use a different seed and a different multiplier. As always, test, test, test. Your objective is to avoid any linear relationship between the combination of the key and the plain text with the ciphertext. If the results are subpar, meaning that a lot of the correlation coefficients are outside the range minus 0.35 to plus 0.35, it might take no more than replacing one row or swapping two rows of the tableau to fix the problem.